Hello, everyone. Hello, everyone. Welcome to today's webinar. My name is Gozo Wang, and I'm the account manager of Mordex 3D EMEA team. The topic of today's webinar is eliminating CMark and voice in injection mold parts. So before we start today's webinar, Mordex 3D would like to hope you all stay healthy, and I think we believe we can go through this difficulty together. So now let's start today's webinar. So today we'd like to talk about seam marks. The seam marks belong to a kind of the defects of the injection molding process. We can roughly classify the defects of the injection molding process as 3 groups. The first group is the dimension. So just like the warpage or like the shrinkage, this kind of defects, just like the dimension of your product is different to your design value. And the second group of the defects is about the stress. So just like the welding line, when we have several mill fronts mixed together, it will become the weakness in our structure, and it will become the defects about the stress. And the last one is about the surface quality. The seam mark belongs to this kind of defect. So what is the seam mark? The seam mark is when we put our injection molding part under the bright light, sometimes we can see there a little bit ups and down on the surface. And this kind of ups and down is not from the cavity design. And we call this kind of defects as seam marks. So in today's webinar, we will talk about what kind of root cause will cause the seam marks, and we will also talk about how to deal with seam mark. And the most important part is we will also show you several examples to show you how to deal with seam mark by using Mordex 3D. So why there is seam mark? Here we will also talk about voice, because the seam marks and the voice, they are actually come from the same root cause. So they come from the uneven shrinkage. We can see in the picture here on the left-hand side, this one we have a min plate design, and when we try to reinforce the structure of this min plate, we may add the rib on it. So we can see, and we can figure out there is thickness variation on this design, and the thickness variation will become the difference of the solidification in the mold when the molten material in the cavity space. And we will get the seam mark just on the opposite side of the rib. And on the right-hand side, this one, there is also the thickness variation. But this time, we get the voice just in the middle area of our part. In the next slide, we will explain why there is different defects based on the same kind of root cause. So now, we would like to explain why there is difference between seam marks and the voice. So we can see in the picture below, this one we have a design, and this design is structured with the thickness variation. So when we fill the cavity by using the molten material, the material will try to, when the cooling system keep working, the melted material around the cavity surface will be solidified at first. So just like this, it will become a solidified layer just around our injection molding part. And at this moment, the core area, the material in the core area will also shrink because the temperature in the core area will also keep solidified, and with material shrink in the core area. So this is the same root cause, but we will get a different result, because if the solidified layers is strong enough, so what I mean is the shrink in the middle area cannot move the solidified layer, and the shrinkage in the middle area will become the voice just inside the part, and that's the reason of the voice. But if the solidified layers is not strong enough, and the shrinkage in the core area will pull the solidified layers in, and it will become the seam mark just on the surface. So even the seam marks and the voice, they come from the same root cause, but it will become the different defects. The seam mark is the defects on the surface quality, but the voice is the defects in the middle area. So it will become the defects about the structural stress. And because the seam mark is belong to a kind of surface quality issue, so there are two features that will affect the visibility of the seam mark. The one is color, because we ever talk about we can put our injection molding parts under the light, and we can see the reflection of the light and try to check if there is seam mark or not. So the color of the injection molding part just will become a kind of the background when you try to check the seam mark. If we choose the black color to make our part, the background of it will become the black background, and it will easier to be spot if there is seam mark. So the way to help her to ignore the seam mark is we can try to choose the color of the part as more light color. For example, we can choose the gray one, and it will help us to ignore the seam mark, even though the seam mark is still there. And the other feature, it will also affect the seam mark. The visibility of seam mark is the surface finish. Is in the middle picture, this one, we can see there we can figure out there is seam mark, but the surface finish design on this part is with higher surface texture. So it can make the visibility of the seam mark a little bit diffusion. So even the seam mark is still there, but sometimes we cannot figure it out easily. But if the part design with the glossy surface, just like this one, then the seam mark is very easy to be spotted, and we need to face the seam mark more seriously. We cannot just ignore it. So now let's go back to how to eliminate the seam mark. There are two ways to eliminate seam marks. The first one is we can work on the geometry design. For example, because the seam mark because we know the seam mark come from the thickness variation, so we can try to optimize our geometry design. And we will also offer several ways for you to deal with the seam mark based on the geometry design. And the other way to deal with the seam mark is we can work on the shrinkage situation. The idea about this is we can try to optimize our processing conditions. So based on this way, we can try, for example, we can try to optimize our packing process. Then we can have this shrinkage situation. This one, we try to offer you a way to deal with seam mark based on the geometry design. In the original design, we can see we have a min plate and because we try to reinforce the structure of this main plate, so we have 3 ribs on it, and we can also see the ribs with thickness, and we can image. Based on this kind of design, there will be serious seam mark and voice on our injection molding part. So the way to deal with it is we can try to separate the rib to several thinner ribs, just like this, the better design here. So we separate the thick rib into 2 ribs or 3 ribs, and we can get a more even shrinkage situation on this structure. And we also suggest our user to use the value to design your rib thickness. We can use about 50% to 80% of the thickness. We can use we can use about 50% to 80% of the main plane thickness to design our rib thickness. And then we can also deal with the sigma by editing the shrinkage situation. So we can work on our tooling design. We can try to get a more cooling system design, have the cooling channel on the right position. It can help us to get a better cooling result, and we have a more even shrinkage situation. Or we can just try to set up our gate location to a better area. So you can use Mordex 3D to try the different location to set up your gate. And for example, if we set a gate location in an area with thicker thickness on our part, we can get a better shrinkage result, better packing result. Or we can also just edit the dimension of our gauge. And here we also offer you several ways we can optimize our processing condition. For example, we can just increase the packing time or packing pressure. It's a very direct solve. Or the other way is we can also increase the cooling time, because if we put our injection molding part in the cavity more longer, then the solidify layers of our part will increase, and it can help us to keep the surface quality of our injection molding part better. And now we would like to offer you, we have 2 results in Mordex 3D that can help you to predict and check the situation of your part about a seam mark. The first one is called seam mark indicator, and the second one is seam mark displacement. So the seam mark indicator is we use a theory to calculate the relationship of the volumetric shrinkage everywhere in our cavity, and give you an index to show you the seam mark indicator. And this result is better for a seam mark in a larger area. So just like this remark, if we have this kind of structure, we have a rib design, and this rib with a very thick area. So we have this structure with thickness variation in large area. Seam mark indicator is very great for this situation. It can help us to predict if there is the risk of the seam mark will be generated or not. And the second one is seam mark displacement. This one is also based on the volumetric shrinkage, but this one is better for the situation of the rib with the thin rib. So just like this remark, we use the different method to help you to predict the seam mark. And we can see on the right hand side, we offer the result. The upper one is the result of the seam mark indicator. And we use this kind of geometry, and we can see the result shows us the location with higher risk with the seam mark And the lower one, we can this one is a fan. The fans around the center structure, just like the ribs around the center structure, and we can use sigma displacement to help us to predict the sigma situation in the middle structure. We can see the result actually show us the risk and the value of the sigma. So by the way, the sigma displacement is better for, it's especially good for predict the sigma displacement. So it can help us to give us a value of the sigma. So how it means how the sync of the sigma, and the sigma indicator is better for show you the risk of the sigma, and it is an index. So now here we predict and we prepare 3 cases to show you how to deal with sigma and how the capability of Mautic 3D can help you to deal with sigma. The first one, this case is we do the experimental experiment, and we compare the simulation result and the experimental result. So we do the validation to show you the capability of Mautic 3D. We really have a tooling design. We can see we have a tooling design to manufacture this plate, and this plate with 4 ribs on each, and we on purpose design the thickness of these 4 ribs with different thickness, and we really manufacture it. We can see the product on the right hand side. Here is the dimension of this tooling design. We the thickness of the main plate is 1.5 millimeter, and the 4 ribs with 1.8, 1.5, 1.2, and 0.9 millimeter, and we get the experiment to get the measurement on the thickness of them. Here we show you the simulation result. The result here is the volumetric shrinkage. And we can see here we have 4 pictures. These 4 pictures with different, with the volumetric shrinkage based on the different rib location, and this location with the different rib thickness. And we can see on this picture, this location with the thickness, we have 1.9 thickness on the rib design. So we can figure out the volumetric shrinkage in this area with a lot of different. So it also means there is very high risk to get the sigma in the opposite side of its rib, because the material in this area will try to shrink a lot, and we will have high possibility to get sigma in this area. And we can also figure out in the different rib thickness design, the volumetric shrinkage in the rib area will be different. And when the thickness of the ribs is thinner, the volumetric shrinkage in the ribs in the rib area can be ignored. So it also match the suggestion we ever mentioned earlier. We suggest to use the thickness of the rib by using the 50% to 80% of the thickness of the main plate. And then we do the measurement on our injection molding part to measure the sigma situation on our part. On the left-hand side, this one is the simulation result. This one is the sigma displacement, and it shows us how the sigma, how deep the sigma is in this 4 area. And we also do the measurement on the part, and we can see the value. The result of the measurement value is very small. So we need to use the accurate equipment to do the measurement. And we get a very good correlation between the simulation and the experimental result. So it really shows us the capability of Model 3D. Model 3D can help us to predict the sim mark displacement and the sim mark situation. So we can use Model 3D to do to optimize our design, to optimize our geometry design, and do this kind of try and error just in a virtual environment. And the second case, this case we would like to show you a real case to deal with CMark and a real case to do the edit on our geometry design. And we also use Model 3D to predict how the optimized result will be by using a virtual environment. And we also really do the tooling update to do the result with better sim mark. So the result will be no sim mark on our product. So this product, the product here is a cell phone case. Here is the dimension of this cell phone case. And here is the tooling design of this cell phone case. So we have a hard runner, and the hard runner connect with a co-runner system with 6 runners. Here is the detailed geometry of the cell phone case. You can see on the bottom area of this cell phone case. In this area we have a snap fit joint design. So we have a clip here, but this geometry design is not great for the injection molding process because the thickness there is too thick, and we really get the bad surface quality result on our trial molding. And when we do the simulation on Model 3D, we also get the same situation on our result. We can see here is the maximum variance shrinkage result from Model 3D. We can also get there is high risk of the sim mark in the same area with the snap fit joint design. So now we try to improvise our geometry and try to eliminate this sim mark in this area, because when we do the injection molding process to build a cell phone case, we hope the surface quality of cell phone case is perfect, because this kind of product always with high value. The way we did to optimize the geometry design is we try to decrease the thickness in this area. So we do some edit on our clip design, and we use Model 3D to predict how will this design, how the sigma situation will this design. And we also check the maximum dimension shrinkage on the same area, and we can see the high risk of the sigma in the bottom area is no longer there, and it will really help us to get a better surface quality. And then we really compare the injection molding part with the original design and the revised design. On the left-hand side, we can see in the bottom area, we can see there is a very serious sim mark there, and we use the brightness deviation to help you to see the sim mark in this area. And when we do the edit on our geometry, the sim mark is no longer there. So on the right-hand side, we can see the surface quality is much better. We can almost cannot see there is any sim mark. So by using this way, we can deal with the sim mark by using Model 3D. And the last case, this one, we will like to also show you a case to deal with sim mark. And the way to deal with sim mark in this case is we use a different process. We use the double shot molding to deal with sim mark. This one is the cast. This one is a handle of the GPS screen, and here is the dimension of each. And now let's check the thickness distribution on it, because we can see in the handle area there is a very high thickness variation in this area, but in the bin area the thickness is pretty smooth, it's pretty even. So based on this kind of geometry design, we have high possibility and high risk to get a seam mark in the hand area. And on the right hand side, this one is more easily flow from the measurement in our injection molding process. This one we use the one shot design. So based on the one shot design, we really get the bad result on the seam mark. When we check the seam mark indicator, we can get a very high risk in the hand area. And when we check the seam mark displacement, we also get very high value in this area. So this kind of result means the surface quality of this one-shot design is pretty not good. And we really get the same result from the reality. We can see in this picture, there is seam mark in the hand area. So now we try to do the revised design on this geometry. The way we deal with it is we try to separate the original geometry to two parts. So the idea is we keep the first shot, we separate them to two parts, and we keep the thickness on the second shot much more even. So even though there is still thickness variation on the first shot, but the seam mark will happen, even the seam mark will happen on the first shot, but the second shot will just cover the seam mark. And because the thickness variation on the second shot is very low, so we can get a better surface quality on the second shot. So we can see here is the animation of this two-shot design. The red area is the first shot, and we try to inject the head area by using the second shot. And now here we show you the result based on the original design and the revised design. So the original design means one shot, and the revised design means two shot. And when we check the seam mark indicator, in the one shot design, there is very high risk area to get seam mark. But in the two shot design, you can see the seam mark indicator is much more even. So what it means is there is high risk to get the seam mark. And when we check the seam mark displacement, the one shot design with very high value, so there is very bad situation. And when we check the two shot design, we can see the seam mark displacement in the head area is much more even, and the value of the displacement is much lower. So today we show you, we talk about the seam mark, and first we talk about what kind of locals will generate the seam mark, and we offer several ways to help you to deal with seam mark. And we also show you some example to show you the capability of Model 3D. Model 3D can help you to predict the seam mark and can help you to deal with seam mark in a virtual environment. It can really save your time and money. You don't need to really do the tooling update before you get a great predict. And we also really show you several examples. We deal with seam mark. We do the geometry update, and we also did the process update. So by using this kind of update and in the environment of Mautic 3D, we can really help you to predict SIG mark